Hello and welcome back. My name is Stefano, and in today's video we'll be doing a complete Omada setup guide with the hardware you see in front of you. We have the ER605 router, we have the AX3600 wireless access point with Wi-Fi 6, we have our hardware controller, and we have our 10-port PoE Plus switch. So this is everything we're going to use for today's setup. And without any further waiting, let's go ahead and get started. Here's a bit of a visual representation of what our network looks like. You can see that the internet comes into our AT&T gateway, and then from our gateway, it is plugged into the WAN port here. So now our router is able to have access to the internet. And then we have the router plugged in on the LAN port here to the first port on our switch. So now any devices plugged in the switch will have access to the internet as well. And then from here it's pretty straightforward. We have our wireless access point that is receiving PoE, that's power over Ethernet, from port 2. We have our OC200, this is our hardware controller. This is what is controlling and configuring our entire network that you'll see here shortly. This is also getting PoE, or power over Ethernet, from port 3. And then I have my Mac Mini here plugged into port 4, so I can actually configure this network and interact with it as needed. Now, some of the networks we are going to create are the LAN/parents networks. This is basically what you can think of as the admin network. I plan to give it a IP range starting at 192.168.10.1, and then we'll have a kids VLAN and network that will be isolated from everybody else. So this will be 192.168.20.1, and then we have IP cameras as well as a guest network here. And that is pretty much how we're going to move forward for the rest of the video in terms of creating our networks and VLANs. Now that we have everything plugged in, we are going to have to figure out what the IP address is of our OC200 hardware controller. There are many ways to do this, but the way that I'm going to do this is by using the terminal window you see here and typing in the command nmap 192.168.0.1/24, because I want to try and search all 256 possible IP addresses here, and this is going to go out and try and search for all of those IP addresses on any ports that may be listening, and it's going to report all that stuff back to us. So we just have to wait a few moments and we will have that information. Okay, Nmap has completed here. As you can see, it went through the 256 IP addresses and found 5 total hosts. So if we scroll back up here, we'll be able to see that it's discovered some interesting IP addresses, and I believe, I'm almost willing to bet, by default, that the ER605 router is the 192.168.0.1 address. And I'd be willing to bet money that this is our OC200 hardware controller. So we're just going to try this one and see if we are lucky. This is probably the the switch here, and this is most likely the AX 3600 wireless access point. So let's enter this in and see if we get lucky. Alright, so I just pasted this into my address bar, and voila. So this brings us right to the Omada controller. So we can just hit let's get started here. And we can give our controller a name. I'm just going to leave it as is, the OC200 here. But we are going to change our time zone. My particular time zone is Central Time. So I will select that. And you don't have to select any of this stuff, but I'm going to. I'm just going to go ahead and select Home here, and then hit next. So it looks like it's already discovered our access point here. So the access point is also known as the AP6600HD or the AX3600. We're going to leave this alone for now and just hit skip. We're also going to skip this part as well. And now we're going to have to go ahead and create an administrator account for our hardware controller. So I'm just going to go with admin SPX Labs. We don't have to enter in an email here, but we'll skip that for now, and then we'll do a super secret password that no one will ever be able to guess, and we're just going to turn off cloud access for now as well, and then go ahead and hit next. Okay, so we've got all of that created. Let's go ahead and finish, and here shortly we should be brought into the login screen. That happened much faster than I thought it would. So we need to log back in. Okay, great. We're all logged in and we're looking at the dashboard within the OC200 hardware controller. So let's just navigate over here to devices and we're going to click on this link and we can actually see all of the devices available for adoption. I'm going to go ahead and start with the router first. So I'm going to click adopt here and the status here changes to adopting and we're just going to wait a moment for this to happen. Okay, after a couple of minutes, our ER605 multi-WAN router has been adopted, and I'm just going to click adopt on both of these devices at the same time. So this is our switch, and then of course the access point itself. And once those are adopted, we will move on to the next part. Okay, great. All of these are adopted. Now before we go off and start creating so many networks, we're actually going to change this IP address subnet here to be something a little bit more memorable, at least for me. So we're going to go here to the gearbox, click on settings, then we're going to navigate to wired networks, we're going to click on LAN, and here we have a default LAN created for us, and we're actually going to edit this by clicking the edit button, and we're going to change the gateway/subnet address to 192.168.10.1. We're going to update the DHCP address, and now any device that is added to this LAN network will pull an IP address of 192.168.10.1, and we're going to go ahead and hit save. Okay, great. Now that these changes are going to go take effect, there's one thing we're going to do after making that change, and that's going to our controller, and we're going to set a static IP address here, so 192.168.10.2, and the subnet mask is 255.255.255. 0 is fine, and of course our gateway will be 192.168.10.1, so this will be our router or gateway. We'll leave our we'll say our DNS is also 192.168.10.1, and we won't have a secondary one for now. So the reason why we want to do this is so that way this IP address never changes and we'll know what it will be in the future, so we can come back to the hardware controller after making our changes. So just going to click the save button here and all of this should update for us. Alright, and now that the save has been accepted, we're just going to have to accept the SSL certificate again and log back in, and we should be good to go. Alright, cool. Let's check the IP addresses of our other devices here. Apparently we missed our heartbeat here, and our other devices are being adopted, so this might take a little effort. That's interesting. Let's go ahead and click retry and see what we get. Alright, that took a little time, but now all of the devices have a 192.168.10 address, which is perfect. But we're also going to want to change these to have static IPs as well, so that way we can more easily remember what they are in the future, and also they won't obtain new IP addresses without our consent. So you can already see that we have our router here as .1, our OC controller is .2, so I think we should change this device here, so this is our switch, to .3. I believe we can do this by clicking on the device and then going to config, scrolling down to IP settings, and clicking the radial button here for static, and then just typing in the IP address we want. So we will say 3, subnet mask, we've already seen, but it's 255, we'll say .0. Our gateway is our router, 10.1, and we're also going to just pretend like that as our DNS for now, and that should be good to go. Hit apply. It says that was successful. We'll just go ahead and close out of here for now, and then we will do the same thing for our access point here. So clicking on it, going to config, static IP address, and giving it the IP we want. Okay, we applied that setting. Now we just need to wait for both of these devices to pool their new IP addresses, and we will be pretty much good to go to continue setting up our network from here. Great. our devices got their new IP addresses, they're configured and adopted, so we can go ahead and start creating our LAN network. So we're going to click on Settings, go to Wired Networks, go to LAN. We're going to create a new LAN, and the first one that we're going to create is called Kids. We're going to click on LAN here so they will be able to have access to the internet. We're going to give them a VLAN ID of 20. This will be important for later. And the subnet they will be on is going to be 192.168.20.1. So any device that is plugged into the switch that is on this VLAN and or on this wireless network will get an IP address in this range. And it's a pretty big range, 254 IPs available. I clicked on Update DHCP range, and we are done making changes here, so we'll go ahead and click Save. Next, we're going to create our IP camera LAN. We're also going to allow these to have access to the internet so we can reach them if we need to in the future. We're going to give them a VLAN of 30, a VLAN ID of 30, and 192.168.30.1, and also a pretty large subnet here with 254 IP addresses. We're just going to click Update, hit Save again, and we're going to create one last network, and this will be the guest network. Click on LAN. We'll give it a VLAN ID of 40, 192.168.40.1, 24, update, save. Great. Now we're going to want to create some wireless networks, so that way if we are using a mobile device, we can obviously access these different VLANs or networks. So we're going to click on wireless networks here. We're going to create a new wireless network, and we're going to start with the kids. We're going to let them have access to both bands. We don't need the guest network enabled for this. We're going to leave it as WPA Personal here. If we try to use WPA Enterprise, we would need a radius server. So let's go ahead and give them a super secret password for when they try to log into the wireless network. We're going to go to Advanced Settings, and we're going to enable the VLAN, and the VLAN ID we created for the kids was 20. So we're going to hit Apply. Now we're going to create another VLAN for our IP cameras. So just in case we get any wireless IP cameras, we will have that here, and we're also going to give that a secret key, enable. We're going to give this a VLAN, or give it its VLAN ID of 30, hit Apply. We're going to create another network. This one's going to be called Guest, and we're going to enable Guest here, so it's going to create all of those firewall rules to disallow it from accessing the other subnets. We're going to hit enter in a super secret password. It's VLAN ID of 40. And finally, we're going to want to create a admin, or what I'm going to call a parents wireless network. And we're going to give this a super secret password as well. And we could specify the VLAN here if we wanted to for the default LAN group, but we don't necessarily need to. So the default LAN group has an IP or VLAN ID of 1. We're not gonna modify this. We're just gonna leave this as is, and we're gonna hit Apply. Cool. So all of that is done and set. Now we're gonna want to create some profiles here, or a switch profile, so that way all of these wireless networks can be accessed from a switch. So let's go over to wired networks, and we're going to click on LAN here. We're going to create a new profile. So there's a bunch of pre-created profiles. We'll ignore these for now. Create a new profile. We're going to call it all VLANs. So the native network, of course, is going to be LAN. And we're going to go ahead and tag all of these VLANs that we created. Now, you don't see the parents VLAN here, and that's because the parents VLAN is technically part of the LAN, so nothing to worry about here. We're not missing anything. We're going to hit Save. Now we're going to go over to Switch Settings, and we're going to edit our port profiles, or port profiles. That way we can make sure that our wireless networks have access to our switch. So by default, it is already set to all ports or all profiles, but we're just going to go ahead and limit it as necessary. So I plugged my wireless access point here into port 1. So let's go ahead and click on edit, and we will be able to find in here the profile for all VLANs, and we'll hit apply. So now only the VLANs that we created, the wireless VLANs that we created, or wireless networks that we created, will have access to this port here, and we are pretty much done. This is also where you could limit the specific ports to specific VLANs. Let's say that the kid's Xbox 360 was plugged into port 4, and we could just limit that specific port to that VLAN if we wanted. All that can be done here in the switch settings under the ports and the profiles. Sweet, let's move on. Now we aren't quite done yet, so we're going to want to isolate the kids network from the rest of the VLANs or networks that we created, because by default all of these networks will be able to communicate with each other, and we don't really want the kids to have access to the rest of these networks just in case they try to mess with any of our configuration or access things they shouldn't. So to do that, we're simply going to go over to network security. We're going to click on ACL, and then we're going to go to EAP access control list. So this is our wireless access control list. We're going to create a new rule, and we're going to call this deny access to all VLANs. Of course, it'll be enabled, it'll be deny. So anything from the kids network, so our source here is the kids network, that is going to go over to our LAN or IP cameras and our guest network, just to be safe, will now be blocked. So they will no longer have access to any of the other networks because we have blocked inter-VLAN routing. But we still aren't done here, because even though we've done this, the kids can still have access to our router and also to the OC controller. So we're going to block both of those as well. Now, to do this, it's pretty simple. We're going to click on profiles over here. We're going to click on groups. We're going to create a new group. We're going to call this group deny OC and router. We're going to say IP port group. We're going to add a subnet here of 192.168.20.1. So this would be the default route to the router. We're going to put 32 in here because we want to block just specifically this IP address. We're going to add another subnet here for our hardware controller, 20.2, and we also want to block that one specifically. And then for fun, we are going to block port 80, so this is the HTTP port. We're going to block port 8080, really just for fun. This is also another heavily used HTTP port. We're going to add another port here of 443. So this is for secure access to these web interfaces. And I think that should be good for now. So we're going to go ahead and click apply. Okay, great. So now if we go back to network security and go to our wireless access control list, we're going to create another new rule, and it will be deny access to OC controller and router. We're going to say anything from the kids network. We're going to deny access to those. And that's really just in case here, so that way they can't tinker around with anything as well. And that should be good to go for our wireless access controls. So let's go ahead and test this out. Okay, so I've connected to the kids Wi-Fi network here, and we can see that I've pulled an address of 192.168.20.248. So things are looking good so far. Let's go ahead and see if we have access to the internet, and it looks like we do. We're getting a really nice download speed there. And let's go ahead and see if we can access our hardware controller, or I'm sorry, our router at 192.168.20.1, and that is blocked successfully, and we can go ahead and try 192.168.20.2 for our hardware controller, and that does not appear to be working either. And finally, just to be safe, let's go ahead and try and ping an address on another network like the router, and that is not pinging at all. And finally, let's go ahead and try and ping my workstation that is on the 192.168.10.1 network, and that is also timing out. So that looks like it's all working correctly. So I think I've given you guys enough information to make your home networks a little bit more secure and a little bit more robust at home. And I think that we're going to do a more detailed video in the future. At least that's what I have the feeling for. And so with all of that being said, I think this is a great point to end this video. And of course, I want to thank you guys all for watching. And I will see you on the very next one.